Great. Welcome, everyone, to today's open day. So we are from the UCL Institute for Environmental Design and Engineering. And today we're going to talk about our 4 MSc programs. We have Smart Buildings and Digital Engineering, Light and Lighting, Environmental Design and Engineering, Health and Wellbeing, and Sustainable Buildings. So I'm going to start with the program that I lead, which is Smart Buildings and Digital Engineering. We'll give a quick introduction to the 4 programs, and then we'll open the session. We'll open the floor to you to ask any questions you might have on either or any of these programs that we are delivering at UCL IED. So welcome everyone again. Great to see so many participants. I will start quickly with the Smart Buildings and Digital Engineering program. So I'm the program lead, and I just want to give you a quick introduction of why this master's was set up in 2018. So when we started developing the masters, there was a clear need for a new set of skills in the design of buildings, particularly looking at, particularly looking at the low carbon, the solutions to a low carbon challenge. So to improve the sustainability of buildings, the smart buildings can be a tool, but the techniques and the knowledge which is in traditional engineering, didn't provide enough skills for the engineers of the future. Therefore, that's why we set out and we started developing these masters in 2018. We can see that the government is now, in the last few years, has also improved their plans for smart technology. So they have been funding around that, and there is a keen interest from companies to then move into the digital engineering journey. And our program is to develop these technologies and skills and knowledge to really drive sustainability with the help of smart buildings and digital engineering. So the points that we will explore during the year, so it's a 1-year master's, you will learn the scientific principles underpinning the way buildings and their systems are designed, and also the way they are operated. We'll also have a look at data. So of course we have a number, now we have a large number of data, large amount of data that we can collect, process, but also we need to interpret, and we need to use data analytics to really improve the operation of buildings. So how to gather value from this data is part of our program. Also, we really value an integrated perspective of buildings, its systems and users, particularly for sustainable and effective operation. And then you will learn the factors affecting integrated building design in relation to sustainable operation. So I'm going to give a quick overview of what you will learn if you come to our program, if you enroll to our program. We have a few core knowledge modules. One is about building physics, for particularly looking at heat transfer and heat balance. And then the second core knowledge module is about engineering environmental elements, looking at different services, and really understanding the physics behind both systems and services and building fabric. Then we have 2 modules looking at integrated design and integrated simulation, one in term 1 and one in term 2. And then we have advanced methods. So one is about advanced building systems modeling. And then the second is about machine learning in smart buildings. Also, we have a number of optional modules, which are you can find from the IED modules, and I've just put a link here and I can share the link in the chat, where you can find the currently offered optional modules. Something I want to say is we are quite a technical program. As part of our skill development, we provide training on a number of software that we think they're valuable for the future engineers of the future. But what we want to teach is not just how to use a tool, because for that you have other options, but it's really what's the underpinning theory behind these tools and how to and that will help you using the tool the best way possible. So we are using a number of building simulation related tools like Energy Plus, Design Builder, Modelica, but also we are using Python as our underlining tool of choice for all our data analysis, but also we are going to give you research skills, develop your research skills. Of course, as in the other programs, you will see that we are not just in the classroom. So we have a number of activities working with industry, listening to the latest development in the field, and also going on site visits. So to wrap up, and then I will send this information. We can send more information in the chat. With the knowledge, understanding, and skills that you acquire by completing the Smart Buildings and Digital Engineering program, you will be a candidate for specialist roles in digitally focused companies, mainly providing services for the engineering, the design, planning, and operation of sustainable buildings. So I have to say the sustainability is at the heart of our work. We take a technical approach, and we hope we are developing with we wanted to develop this knowledge and skills to be the engineers of the future. One more thing that I want to mention is many of our students, there's always some students in a class who after the MSc have gone to undertake a PhD. So you will be well prepared to further your studies in a research career if this is something that is in your interest. So I hope this was a useful overview of what we do, and I'll pass the slides to William. Yeah.
William, you are mute.
Thank you, Valentina. So I'm William Lo, and I'm the current program lead for Lighting MSc. So, the main purpose of this presentation is to give you an overview of the Lighting program, and also for you to ask us any questions that you might have. So hopefully we were able to help you to make a more informed decision about whether you want to apply for the program and study with us. So, So I'm going to kick off this presentation with these two inspiring quotes by Louis Kahn and Peter Sieb on the sideline. The sun never knew how great it was until it hit the side of a building. A glass house without shading is like a Porsche without brakes. So who we are part of the Bartlett, the Institute for Environmental Design and Engineering, and the Lighting program was launched back in 1987, 36 years ago, to meet the demand for specialist lighting expertise in the UK. And this program is one of the world's most comprehensive courses in lighting, and also this course is one of the very few courses in the world that covers daylight in pretty much every module in some form or another. So when we talk about daylight, we know daylight is free, is top quality, and the way we design building to emit light, to manipulate light, it's been very fundamental to architecture. And if we use daylight strategically, we were able to improve the energy efficiency of a building and also to improve health and well-being as well. So the first question for you is, how do we actually characterize different sky conditions, for example? How do we, explain different kind of like sun and also sky conditions? So the first module is the lighting fundamentals module, where you will learn about the human response to light, the fundamental subjects, a fundamental definition to the subject, and also some very basic lighting metrics as well. And to really enable you to, for example, to understand what daylight really is. And then this module essentially will also lay a foundation and for other modules as well. So we all know daylight doesn't last forever. The day gets dark, so this leads to the other part of our program about electric lighting. So we've got two modules about this. The first one is the advanced lighting design module, and then the other one is the advanced lighting control design module. So these two modules are going to be run by practitioners, where they will provide you with a brief drawing inspirations and ideas from real-world projects. So this program, we do have very strong ties with industry, and students often find it very, very helpful and very beneficial for them as well to learn from these industry experience and expertise. We also cover a wide range of context, from looking at street lighting to lighting for hospital, museums, and schools as well. So most of our academics, we look at, but we're also practicing researchers. For example, one of us looks at street lighting, looking at the effects on pedestrian flows in cities. And for example, I look at lighting quality, perception, and also architecture. And we also look at plants as well. So for example, this was a setup in Hearist in our artificial sky, which you'll get a chance to see it if you join us. So this particular research will look at the effects of changing lights on the color appearance of plants. So as you can see, our research area really covers from people all the way to plants. So it's all very, very exciting. So altogether, you can take 8 modules. During term 1 and term 2, you're going to take 6 compulsory 15 credit modules and 1 compulsory 30 credit module. And this particular module is a design module. And then in term 3, you will then complete a dissertation. So the expected hours of study per credit is 10, meaning given you're going to take 180 credits, meaning you're going to spend 1,800 hours to do your studies over the course of a year. So it's equivalent to 45 hours a week. So it's very intense, very full on, and it's comparable to a year of full-time employment. So altogether, you can take 8 modules, including lighting fundamentals, lighting applied calculations, evolution of lighting design, lighting practice, advanced lighting design, advanced lighting control design, lighting research, and also lighting dissertation. There are 3 different modes of study. The first one is full-time, where you complete the program in a year, or you can do part-time, where you complete the program in 2 years, or you can choose to study flexible modular mode, where you're going to complete the program between 2 and 5 years. So it really depends on your circumstances. So if you were going to do part-time, you need to come to uni 1 day a week. For example, in your year 1, you need to come on Tuesdays, and if you're in your second year, you would come on Thursdays. So the first module that you're going to look at is lighting fundamentals, where you're going to learn about the fundamental definition of the subject, learn about human response to light, and also some very basic lighting metrics. And then you also get to learn about the evolution of lighting design theories and principles, and also you get to learn about lighting in practice. In particular, you're going to look at, for example, legislations and regulations, guidelines relating to lighting. And you also get to learn about a wide range of lighting simulation tools and learn how to use them in practice. And in particular, we will teach you how to use, for example, Rhino, Grasshopper, Ladybug, and also Radiance. So in term 1, you also look at lighting applied calculations and advanced lighting design. And then you will then further deepen your knowledge in these 2 areas in term 2. And then you also get to learn about how to design a lighting control system to meet people's needs and requirements in different environments, and also learn about the practical implications and consequences of your design. And then you will also get to learn about lighting research, its results, and also its resulting theoretical models in human factors in lighting, and also illuminating engineering. And then in term 3, you will then undertake a research project that will allow you to demonstrate a deep understanding of the lighting knowledge base, sustainability, health, and well-being, which will then lead to your dissertation. So you will draw ideas from all other modules that you've taken throughout the year to inform what you can do for your dissertation research. So as you can see, this program is planned so that everything is continually fitting into each other. So through the year, you'll also be supported by a lot of workshops and activities, because we want you to put theory into practice and to make sure that that you're going to be encouraged to be connected with the real world. So not just within the classroom, but with the real world. So, for example, earlier this year, some of our students have participated in the Study Ready Lights competition, where they design, create, and build lighting installation within 180 minutes. So it's all very fun and very exciting. And also, students would get to use the artificial sky and to learn to measure lights and to understand lighting distribution, for example, in the artificial sky in here East. And then very recently, we actually visited Kew Gardens just last week to really see and experience light, because that is very important in your learning process. So as I've mentioned before, this program is very demanding, but equally is very rewarding and fulfilling. So if you've got any questions, please feel free to reach out to me, or please refer to our Lighting website and all these Twitter, LinkedIn, and Instagram links. And I look forward to receiving your applications. Thank you.
Great, thanks, Villian. I'm just going to take control of the screen, so hopefully I can progress the slides. Hi everyone, so my name's Phil Simmons. I'm the program lead for the Environmental Design and Engineering MSc. And hopefully I can move the slide on. So this course has a long, rich history and has been around for over 40 years. Is one of the oldest in the courses in the UK dealing with environmental issues associated with buildings. And being based in London, we have unrivaled access to industry partners, and many of the graduates from our programme go on to work in some of these leading firms such as Arup and WSP and Fosters and Partners. We also have great expertise within the department, and we do groundbreaking research in the area, and we really do try and teach through our research. So this course tries to tackle some of the biggest issues facing humanity. I'm sure you're all aware of the climate crisis, and the IPCC issued a code red warning for humanity. So buildings are a key contributor to global CO2 emissions and account for around 40%. So we really do have a big task on our hands, and as part of this course we try to address this problem, and we know that there'll be increased flooding, heat waves and droughts in the future, so we need to design and retrofit our buildings such that they can deal with these problems. There's also interlinked challenges with energy security. So we had the recent energy crisis, which led to high electricity and gas prices, and this was something that we had to deal with in the built environment. And in the UK, for example, it has led to issues with fuel poverty and people finding it difficult to heat their homes. So we try and address some of these issues in terms of both the mitigation and the adaptation of buildings. And we also need to consider how to design healthy and usable buildings for occupants. And we think as EDE that the best approach is through a multi and interdisciplinary way of working, such that we're not forgetting about unintended consequences, and we can design healthy and usable buildings. And we try and address challenges with the performance gap between design and operation, and by trying to also address gaps between various disciplines. So an engineer and and an architect may have different ideas in terms of the best design approach, and we try and come up with an integrated, holistic way of designing buildings. And we're not just open to engineers and architects. We do take applications from various different fields because we're interested in all types of approach. And it's this which kind of makes us unique within IEDE, in that we have such a wide variety of expertise in various fields. So you can see in the image on the right, the various components that we have in IEDE. So when it comes to doing your dissertations with us, we do have lots of different topics. So any area that you want to really focus on, we can do this, and we can do it through a variety of different methods. And for example, there's systems thinking and system dynamics. There's detailed modeling in terms of building, and also geospatial urban modeling, and then also monitoring and measurements. And we're really at the forefront in the field and doing research as it happens. In terms of what you'll be learning, so you'll be learning a lot about the policy and regulations based around buildings, different types of monitoring and measurement and testing methods, building simulation and analysis of data, and then you'll be really honing in on your research skills. Here are a list of the core modules and some of the optional modules which you'll have the opportunity to take. I'm not going to go into these in too much detail, but if you want to find out more about these, then please do go ahead and look at them on the graduate prospectus. There'll be a link to that at the end of this presentation. In terms of our methods of teaching, we employ lots of different techniques. So as well as lectures, there'll be group work, seminars. You'll have the opportunity to present your work in poster sessions, and also undertake some hands-on modeling and monitoring. So we really learn through doing. And an important part of the EDE course is the networking opportunities. So we have a variety of social events, and also we have, during the induction week, a buildings walk where we walk through London and look at the various types of architecture and how some of the buildings have been designed. And then in October, we go on a trip, which is a 2-night trip to the Sustainability Centre in the South Downs, where we have both a mix of fun and also educational activities. And you can see some of the things we do in the pictures here. We created EDE out using a thermal camera, which was one of the fun things we did. And so just to finish off, we really welcome your application to the programme to join a long list of high achieving professionals. And just to also note that some of the academics who teach you on this course are previous EDE graduates. So they loved it so much they decided to hang around. So thanks for listening, and look forward to answering any questions. And there's a link down there to the prospectus.
Oh. Hey, see here. And you hear me? Okay, thanks. That's all. Can you see me? Okay, terrific. Welcome, everybody. Looks like there's some people that perhaps hope that ESDA would have a presentation here today, but I'm afraid they're going to be on a different day. You'll have to do a little research and sort that out, but I hope you will consider the programs at the Institute for Environmental Design and Engineering, because all of us have really great things to contribute. My name is Elizabeth Cooper. I'm the program lead for Health, Wellbeing, and Sustainable Buildings MSc. And how do you advance it? There it goes, just like that. So I'll give you the same sort of presentation here. Why choose this MSc? Like the others, you will get an opportunity to learn from top experts and leaders in the field, both academics as well as members of our advisory panel and industry connections. You'll acquire knowledge and skills that enable you to make a real difference in your own career and to society through the built environment. You'll have an edge when entering the job market. Right now, health and well-being is becoming more and more a part of sustainability teams. These are critical roles that are right now being filled with people that will not have the same level of knowledge and skills that you would have coming out of this degree. So it gives you quite an edge in the industry. Health and well-being, I would argue, is the core of key societal at the core of key societal challenges. Whether that's climate change, energy efficient building design, and how it affects occupant health, well-being, and productivity, which is a main theme that we'll cover in the program, and the impact of climatic changes on health. So how do rising sea levels, increased weather, extreme weather events, increased temperatures, how do those affect people's health, and how does the built environment help to mitigate some of those things? Air pollution. How do we design and operate buildings to minimize the effects of air pollution, both from outdoor and indoor sources? Again, related as well to climate change. How does changing climatic conditions affect our air, and how do we mitigate that in our built environment, or through our built environment? We have demographic changes, global health issues. How do we design the built environment for an example, for our aging population, or for a population that has quite diversity of needs? What are the challenges of growing planetary population levels for building designers? So how are things like migration, whether that's because of climate change or because of economic conditions, how do those how does the built environment impact those people? And then sustainable development. How do we support human health and well-being whilst also pursuing sustainable resource consumption? So these things are very closely linked. And then, of course, economic productivity. Built environments which support health, well-being, and productivity support the economic viability of a place. So all critical core parts of our societies. So what can you expect to learn? Theoretical and applied knowledge. So how buildings and the built environment impact upon health and well-being, and links with sustainability and societal challenges. So these things are inextricable. They're related, and we'll explore a little bit about how that happens, why that's the case. You'll get a chance to learn about design and operational assessment strategies for sustainability that drive the innovation for health and well-being. With hands-on knowledge through tools such as building simulation, applied methods like IEQ, or indoor environmental quality monitoring, or post-occupancy evaluations, standards like those that are required for thermal comfort in buildings. Be introduced to rating systems such as WELL, LEED, Fitwell. There's numerous rating systems and standards out there, and it seems like there's more all the time. Get a sense of what the best practices are, and specific examples of regulation, primarily the UK, but we also tend to look around the world at where our students come from to see how these things are different, where there are similarities. And then this is a true multidisciplinary approach, and the skills are transferable. Understand the key stakeholders and disciplines, understand sort of ethics, research skills, and critical thinking, and communication. All of these things transfer whether you are working in a policy environment or a design environment, or if you go on to pursue more within academia. I just show this as an example of a typical full-time student schedule. We'll start with the first term with 4 compulsory modules: health, comfort, and well-being in the built environment, which is an introduction to the major determinants of health in the built environment. Also, there'll be a methods of environmental analysis, which gives you an opportunity to see some of the tools used and the assessment of health and well-being in the environment. Well-being in buildings, theory and practice, another opportunity to explore the different components of well-being. So that includes the social and psychological, as well as the practical monitoring and assessment tools. And then integrated building design for health, comfort, and well-being, which is an opportunity to integrate these different skills you're learning in the other modules to design in a simulation software and through multiple iterative processes to sort of optimize that design over time. In term 2, you'll focus on indoor air quality, and then change the scale a bit. For those of you who have perhaps an urban planning background, this is where you'll get an opportunity to do a health impact assessment at a regional scale. So an interesting change in the scale of the focus. And then you'll choose 2 of 3 optional modules: lighting and well-being in buildings, building acoustics, and designing inclusive spaces. And then the final term is the completion of the research project of your dissertation. Another wonderful thing about this MSc is it's full of opportunities to visit places like Bath and Bristol, which we just did with the current cohort last month. We also have opportunities to present your work to expert panels, to colleagues and classmates. We have a number of interactive workshops throughout the year, and then other field trips within London, site visits, case studies, and the like. So lots of different activities, not to mention fun social activities with your classmates. So that wraps up the presentation. I don't know, Villian, do you want to take back control?
Yeah, sure. Okay. So thank you very much for the presentations. They're all very, very informative for all 4 programs. So in this particular slide, we've included all our email addresses. So please feel free to reach out to us for any questions that you might have after this session.